Okay, hi everyone. So I'm going to be talking about a kind of insane thing that I did immediately after the InkTank acquisition, which was actually an idea that I'd had about 2 years ago about a really different way to possibly combine the Gluster and Ceph technologies. And I have a couple of points that I want to make before I really start diving into it. First off, this is science. This is not engineering. It's science in the sense that it's about discovering what the world is like, what things are possible. It's not trying to apply that knowledge to serving any particular need. It's not part of a roadmap. I particularly have to mention that because there's some buzz going around, some FUD being spread by people who have vested interests in alternative technologies about how, since the acquisition, we're going to take Gluster and Ceph, and we're going to hack off bits of both of them and leave them bleeding in the gutter. That's really not the case. I mean, there's no particular plan, and my boss here can back me up, to merge the two technologies. That is kind of what I'm doing with this experiment, but it's just an experiment. What I'm trying to learn from this is a couple of things. I'm trying to learn something about the LibreDOS API because I'm curious. I'm trying to maybe tease out some information about which components within each stack are contributing to performance, contributing to failure handling, other things. One way to do that is to sort of mix and match the pieces and see what changes relative to their origins. And partly it's just because combining things in strange ways, you never know what information is going to fall out. I actually did find a couple of fairly interesting things that deserve further investigation, and which may end up ultimately benefiting both projects. Now, I usually hate these slides. I hate the who am I, but I think in this case it might be a bit relevant. So I've been doing distributed network, cluster, whatever file systems for quite a long time. I might be the only guy who's actually run like a dozen of them. So for, besides the ones that are mentioned here where I've actually contributed code to some degree or other, I've run ExtremeFS, MooseFS, HDFS. I don't even remember what some of them were. I did a little project at one point while I was at Red Hat, just taking every distributed file system I could find and running it through the same set of workloads. Just a little side note, it was pretty sad. About half of them crashed. A few of them couldn't even build. One corrupted data. One hung. Ceph was actually one that managed to make it through the exhaustive test of trying to write 10 files simultaneously and then read them back. So it was pretty pathetic. Gluster was another, and I think ExtremeFS was the only other one that actually managed to do that. Now, remember, that was like 3-4 years ago, so they've matured a bit. They could probably maybe write 20 files simultaneously. I'm just the kind of guy who's going to take this opportunity to try and mash together two thought to be disparate technologies. In fact, who here is familiar with both Gluster and Ceph to any appreciable degree at all? So, you people probably realize that we have a lot more in common than that separates us. Yeah, sure, we took some different implementation approaches, but they're both the same sort of scale-out distributed systems. We're using some of the same algorithms, or at least algorithms that are cousins to one another. So it's actually not that weird to be combining them. Now, I know this is Ceph Day, not Gluster Day, but to explain what it is that I'm doing here, I do need to explain a tiny bit about how Gluster works. So the core concept in Gluster is of a translator. This is actually one of the founders of Gluster likes to point out, probably to his detriment, that it came from the GNU Herd operating system project. But the idea is that a translator is a module that takes in I/O requests and then spits out I/O requests in exactly the same form. It's a create on one end, it's a create at the other end. So it's a kind of filter. It can also do fanning out, it can also do routing, it can do things like that. But the key thing is that the interface above and the interface below are exactly the same. So you can stack them in all sorts of orders. You can move them across the server-client boundary, et cetera. This is just how it's implemented. And so most of the functionality that in Ceph you would see as of one piece is actually split out into different translators that are separately loaded, separately developed in some cases in Gluster. So what this diagram shows is that we have some translators on the left, which are the ones that inject requests into the system. Our primary one is Fuse. That's our native protocol that's that it's talking to the Fuse driver, and then it's taking requests and turning that into translator requests. NFS is another one that does this. Then we have something called libgf API, which is a library interface that is also capable of generating all these requests and pushing them through the translator stack. So for example, the Samba integration is moving towards using GF API. The block device integration is using GF API. You can do all sorts of things. It's mostly like libceph.fs. There are some differences. I believe Sage has said that they could probably be harmonized to some degree so that they would look even more similar, so it would be even easier to flip between them. These are all the ways of getting stuff into the system. Then you go through a bunch of translators represented here by ... which is things like write ahead, write behind, read ahead, caching, locks, all sorts of other stuff that's not particularly relevant here. And then the two big boys. DHT is our distributed hash table. It's how we do distribution across many servers. So it's basically performing a routing function. It gets a request in from the user, and it sends it to one of its children, which is one of the bricks. That's our lowest level unit of storage. Beneath that, we have a couple of instances of AFR, advanced file replication. A little thing that I'm never going to do is use advanced in the name of any code that I develop, because 5 years later it's going to look silly. But at the time, it was advanced. So this is our replication module, which takes a request in and sends it out to all of its children. So in this case, it's each AFR instance is sending it to 2 bricks. The DHT instance is sort of round-robining or random hashing among those AFR instances. So this leads to a couple of differences between how GlusterFS works and how Ceph works. In Gluster, we have one role in the I/O path, a brick. That's the only thing. There's one process on the server. It's doing one thing. It's doing data and metadata. In Ceph, in the I/O path, using the file system, of course, you actually have 2 different roles, which may be differently distributed among your nodes in the system. Then, of course, you have them on the Gluster side. You have GlusterD to do management types of stuff. But it's a fairly fundamental difference because it affects a lot of the performance characteristics, both good and bad, on both sides. There's some operations where having it all be one is good. If you're going to do an operation that affects both data and metadata, it's actually really kind of nice if it just has to do one request and those happen together down at the local file system level. If you're doing aggregated operations that have to operate on a bunch of metadata, like say, a directory listing, it's actually kind of nice to have the metadata layer be separate. So they each have their advantages and disadvantages, but it creates a little bit of an impedance mismatch between them. So what did I decide to do? I decided to combine GlusterFS and REDHAT, not Ceph.fs. That would be a much more challenging kind of thing to try and do. Just to see what happens to our data I/O performance and other behavior when we do that. So that's the only thing that's really getting sort of snipped off from the Gluster world and shunted off into a REDHAT cluster. So what we see here is we've got the same things on the front end. We've got Fuse, NFS, et cetera. They're all injecting requests into the system. They're going through some of the higher level translators. I actually had to leave a couple out because the system wasn't really working correctly with them in place. Then it comes down to Glados, and all that's doing is it's saying, is this a read or a write for file data? Yes? OK. we're going to shove it off into this REDHAT world, and we don't know what happens to it after that. Now, what happens to it after that, as you all know, is it's going through all of the REDHAT distribution, replication, possibly erasure coding, et cetera, et cetera, et cetera. Anything else, any of your inode operations, your directory entry operations, et cetera, is staying in the Gluster world. So when we create a file in Gluster, we actually create the Gluster file, and we create a corresponding REDHAT object. So we can alternate between using those two. And then there's a little bit of strange stuff. For example, if you want to know the file size, well, that's not actually correct over in the Gluster world, so we have to go query the REDHAT object. But basically, that's the idea behind it. And of course, I did it in Python. OK, not really. I could have, actually, because in the Gluster world, we have something called gloopy, which is a way of writing these translators in Python instead of in C. Is actually really nice for prototyping crazy ideas. I didn't actually do that, but it was a fun thought that came up at dinner with some of the Ceph guys. Here's a code sample of our incredibly ugly Gluster C code. So this is part of Glados. By the way, how many people recognize Glados as an acronym? How many of you noticed the first slide? What's that in the background? There's a famous line in Portal, which is where Glados comes from, which is, "I liked you better when you were a potato." So that's what I use as my background. Anyway, so this is a pretty typical piece of Gluster code, except for the fact that it's calling out into a completely alien distributed file system. So we call REDHAT read. So this is part of our read path. We check the return value. We do a couple of other things. Yes, we heavily use goto in our code base. I'm sorry. And then the stack unwind strict is basically how we pass stuff back to the translator that called us. So I mean, there's nothing terribly interesting about this. There was nothing terribly difficult about it. I did most of this sitting between sessions at OpenStack Summit, in fact. But this is kind of typical Gluster code. I mean, it's not all that different. I didn't have to do major surgery on everything. It's just another translator that does something slightly different in one place. And it turns out that the REDHAT interface was not hard to work with, libREDHAT interface. But of course, I was only doing the easy thing. I was only doing file data. There's all sorts of really hard things that I wasn't doing. I believe somebody wrote a PhD thesis about how to solve some of these problems. So metadata and especially directories, I mean, I don't do anything with that. I just let Gluster handle it as Gluster always handled it. If anybody really did want to make this real, which I still think is kind of crazy, they'd have to solve that problem. There's a whole lot of server-side functionality in Gluster that gets basically bypassed when we do this. Stuff that would normally be observing the I/O as it goes past, and now since we've shoved it off into REDHAT, it doesn't see it. So that would be a problem. And then, of course, there's performance issues. So, I mean, this should underscore the point that this is just a discovery process. This is not something that could seriously be countenanced as a way to build a real product yet. So what were the results? So I ran a couple of my standard types of tests. So this is a 64K sequential write. And I saw a couple of interesting things. So you can't really see the legend very well, I can tell. The blue line is Ceph, so Ceph 1, yay. And the green line is Gluster, so it's kind of behind. And the first thing that leapt out at me is the Glados version, which I had 2 versions, lags significantly at the lower thread counts. It's delivering relatively little I/O. I don't know why. It does eventually catch up at higher thread counts, but it seems to have a little bit of a startup latency issue. Well, I mean, not startup, but somehow the single thread throughput just isn't that great. So that's something that's worth investigating. Now, the 2 versions here, the yellow version is using AIO, asynchronous I/O. So I'm issuing all these reads and writes through the asynchronous interface. I'm not sitting around waiting for them. The orange line is multi, where I'm actually using multiple libREDHAT contexts. So I'm basically doing a sort of Gatling gun round robin thing between them. So there are two different ways to get a little bit of parallelism among all the requests. Because just using one context in synchronous I/O was just kind of awful. And that wouldn't have been very interesting at all. So this is a fairly interesting result. A much more interesting result was when I started looking at latency. Now these are 4K synchronous random writes. So we see a couple of interesting things. The first is that the positions of Ceph and Gluster have flipped. And this is actually something that I've seen in other tests that I've run, this kind of relative latency versus throughput for the two systems tends to follow that pattern. The other thing that's interesting is that both of the Glados approaches fairly consistently managed to eke out wins over CephFS itself. What's up with that? I don't know. So that's telling us something about the fact that it's mostly kind of tracking the Ceph numbers. So the Ceph numbers, or the Glados numbers, are dominated by the REDHAT performance behaviors. But there's some little difference in there also that's probably worth investigating. So this is exactly the kind of thing that I wanted to tease out of this information, is to see, well, where do things not line up in a fairly obvious way? Here, we've got this little anomaly where the low thread count numbers are just strangely low. So let's look into that. Here we have numbers that are just a tiny bit higher than CephFS. Why? This was all on Firefly, by the way. So it's kind of interesting to look at these things. And really, that's about it. It's a fairly young sort of thing that I've been doing, playing with. If anybody else wants to grab the code. I haven't actually gotten around to pushing it anywhere. I don't have any reason not to. I've been too lazy. So let me know. I'll probably put it up on GitHub or on the Gluster Forge or something pretty soon. Or if you have other ideas or, of course, questions like the frog.